this video we are going to see about Kirchhoff's laws for circuits. We all know Kirchhoff circuits law have two laws. One is Kirchhoff voltage law and other one is Kirchhoff current law. First of all, what this Kirchhoff law provides. The Kirchhoff law provides a means of obtaining enough independent equation to solve for the following in a electrical circuits. In electrical circuits, we have many components or parameters like resistors, current flow, and also voltage. This Kirchhoff's law provides the solution for this parameters equations. This Kirchhoff's law stands for two equalities that deals with the current and potential difference in the lumped element model of electrical circuits. Lumped element model is nothing but some parameters like resistance or voltage sources added to the circuit means that are lumped element model. Next one is this Kirchhoff's law provides the equations to solve the complex circuits. We saw in the resistor tutorial that a single equivalent resistance RT can be found when two or more resistors are connected together in either series or parallel or combination of both, and that are these circuits obey Ohm's law. When the resistors are connected in series or parallel or both the combinations that they obey for Ohm's law, then we have used Ohm's law to solve the resistors equations. However, sometimes in complex circuit such as a bridge or T networks, we cannot simply use Ohm's law alone to find the voltages or currents circulating within the circuits. For these types of calculations, we need certain rules which allow us to obtain the circuit equations, and for this we can use Kirchhoff's law. Okay, first one is Kirchhoff's first law, which is nothing but Kirchhoff's current law. The Kirchhoff's current law is also meant by KCL, states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all the entering currents and the leaving currents at a node must be equal to 0. Then we can add I existing current, number of existing current plus number of leaving current, which is equal to 0. And then we can equate both the currents. Number of entering currents is equal to number of leaving currents. This idea by Kirchhoff is commonly known as conservation of charge. This Kirchhoff's first law, which is nothing but Kirchhoff's current law KCL, is also known as conservation of charge. Next, the Kirchhoff's current law, the three currents entering into the, when you see the diagram, I1, I2, I3 are entering currents and I4, I5 are leaving currents. Then we can get I1 plus I2 plus I3, which is equal to I4 plus I5, which is nothing but number of algebraic sum of entering currents is equal to algebraic sum of leaving current, which is also known as Kirchhoff's current law. Next one, Kirchhoff's second law, the voltage law, which is which is also known as Kirchhoff's voltage law KVL, states that in any closed loop network, the total voltage around the loop is equal to the sum of the all voltage drop within the same loop, which is also equal to 0. In other words, the algebraic sum of all voltage within the loop must be equal to 0. This is known as conservation of energy. This Kirchhoff's law, which is Kirchhoff's voltage law, is known as conservation of energy. Kirchhoff's current law is known as conservation of charge. Starting at any point in the loop, continue in the same direction, noting the direction of all the voltage drops, either positive or negative, the returning back to the same starting point. It is important to maintain the same direction either clockwise or anti-clockwise, or the final voltage sum will be equal to 0. When analyzing either DC or AC circuits, Kirchhoff's current law, a number of definitions and terminology are used to describe, such as node, path, branches, loop and mesh. So we can know what is node and path and branches also in this topic. We can use the Kirchhoff's voltage law when analyzing series kind of circuits. Common DC circuits terms are First one is circuit. A circuit is a closed loop conducting path in which an electrical current flows. As we all know, in an open circuit, there is no flow of current. Okay, the circuit is in off condition. Next one is path, a single line of connecting element or sources. A node is a junction, connection or terminal within a circuit where two or more circuit elements are connected. By using node, we can add some more elements called resistors or voltage source into it. Here you can see the what is node. Okay, this is node. A branch is a branch. What is called branch means a branch is a single or group of components such as resistors or a source which are connected between two nodes. Okay, a group of components connected between two nodes is known as branch. Loop. A loop is a simple closed path in a circuit in which no circuit element or node is encountered more than once. Okay, this one is loop. Okay, this one is node, and between two nodes a number of group of components are connected means that is known as branch. Okay, what are the applications we can get by using Kirchhoff circuits law? These two laws enables the current and voltage in a circuit to be found if the circuit is said to be analyzed. The basic procedure for using Kirchhoff's law is as follows. Assume all voltages and resistance are given. Label each branch with a branch current. Kirchhoff's first law equations for each node KCL, and find Kirchhoff's second law equations for each of the independent loops of the circuit, and use linear simultaneous equations as required to find the unknown currents. Finally, by knowing and using Kirchhoff's law, we can simplify our calculation and reduce more amount of mathematics in solving for circuits and also complex circuits where the resistance and other components are connected in a T or bridge like structure. We can simplify the circuits and also equate the parameters by using Kirchhoff's voltage law and also Kirchhoff's current law.